You ever stop and wonder what keeps the incredibly complex electronics in your pocket from just, well, failing? It's definitely not magic. It's a process, a really intense deep dive into every single detail. It's a hidden world of checks and balances. And today, we're going to pull back the curtain on one of the most critical stages in creating any new technology, the design review. We'll be using the ZED-X20P module as our guide to see what it really takes to get tech right.
All right, so here's our game plan. First, we'll peek inside a typical design review. Then, we'll dig into 3 huge areas from our case study: the power supply, the very foundation, then RF and signal shielding, and finally, the big red flags, the critical warnings that can literally make or break a project. We'll wrap it all up by seeing how this obsession with precision is what makes all of our tech work so well.
So, first up, what in the world happens inside a design review? Honestly, the best way to think about it is like a final exam for a new piece of hardware. It's the absolute last best chance for engineers to catch these tiny, almost invisible flaws that could cause total disasters down the line before a single one ever gets made.
You know, this process right here? It's the unsung hero of our modern world. It's the reason your phone actually boots up every single time, the reason your car's GPS connects, and your computer just works day in and day out. It's all about finding and fixing those problems on paper so they never, ever become problems in your hands.
Okay, section 2. This is where it all begins. The foundation of any electronic device: power. You have to build a stable electrical base. It has to be clean, it has to be reliable, because before a device can do anything cool, you have to get this part perfect. If you don't, well, nothing else matters.
So one of the very first things the review looks at is the exact moment the device is turned on. The initial design was like flipping a giant industrial power switch. Bam! A sudden shocking jolt of electricity that could damage the components. The review flagged this immediately and recommended a new chip with what's called a soft start feature. It's basically like a dimmer switch for electricity, letting the power ramp up smoothly and safely.
And the level of detail here is just incredible. It comes right down to this number: 2. See, it's not just about what kind of power you have, it's how it gets delivered. The review is super specific. For the main power input, it's not good enough to use one connection pad. You have to use exactly 2 pads to make sure the electrical current is spread out properly and doesn't overload anything.
And to make that power even more stable, the review says it's mandatory to add these little tiny components called capacitors, and they have to be placed right next to the main power pin. Think of them like tiny shock absorbers for electricity. They sit there and just soak up any interference or noise on the power line, making sure the main chip gets perfectly clean, stable voltage to do its job.
Okay, with our power totally solid, we can move on to section 3, the signal. If you want clear communication, you have to protect its sensitive radio frequency, or RF, signals from all the electrical chaos happening around them.
This is a perfect example of how one tiny, single component can make or break an entire design. The review found that a key part in the RF circuit, an inductor, just wasn't up to the job. It couldn't handle the 300 milliamps of current the design needed. That's kind of like trying to force a whole river through a tiny garden hose. It's just not going to work. So the review caught it and specified a much more robust component that could handle the load.
Now, to protect those signals even more, the review recommends putting a metal shield around the whole circuit board. The best analogy is soundproofing a recording studio, but for electronics. Like the document says, it creates an effective barrier that stops stray electronic noise from getting in and messing up the signal. It keeps the communication crystal clear.
All right, let's get into our 4th section, and this is maybe the most intense part of any review: the critical warnings. These are the red flags, the absolute show-stopping flaws that could completely derail the project if they aren't fixed, like yesterday.
Wow. I mean, you can't get much more direct than a warning like that. The review board is basically saying, in no uncertain terms, that the USB port design might be okay for a lab prototype, but it is absolutely not tough enough for a real product that people will buy. Shipping a device with this flaw would be a total recipe for disaster.
Okay, so that warning sounds pretty bad, right? But the fix, thankfully, is really straightforward. The review lays out 3 simple steps. You disconnect the two data pins, just leave them unconnected to anything. And then you take the USB power pin and connect it straight to the ground. That's it. It just safely and completely disables the port that isn't ready for the final product.
And you know, sometimes the most critical instructions are about what not to do. Just look at this do not list for the reset pin. You can't add extra parts to it, and you absolutely cannot mess with it during the very delicate power-up sequence. Why? Because the chip has its own carefully timed internal process for booting up, and any of these things would interfere with it and stop the device from ever starting up correctly.
So that brings us to our final section, precision makes perfect. After seeing all these little details, it becomes so clear that this incredibly careful review isn't just some one-off thing. This level of precision, this obsession with getting it right, is the standard for reliable tech. It's the invisible foundation that just makes our world work.
So when you put it all together, you just see this amazing picture of diligence. We saw them demand a soft start for the power, specify the exact right parts for the RF signal, build a shield to block out noise, flag a USB port that was a disaster waiting to happen, and create a strict do not touch list for that critical reset pin. Every single detail gets put under the microscope.
So, the next time your GPS locks on in a split second or your phone boots up without a single glitch, maybe you'll think about this, about the invisible process that made it possible. You'll know about the engineers who sweat every single one of these tiny details so that the technology in our lives just works.